Okay, in this quick tutorial, I'm going to show how to do insertion sort with C. I have a template set up right here, written in C, and it basically has a print array function and an insertion sort function. So basically, the print array is just going to be kind of for, to see what's inside the array after performing the insertion sort, and the insertion sort will perform the actual sorting. The idea behind insertion sort, first and foremost, is to sort the array, either largest to smallest or smallest to largest, or it could be characters, it could be structures, whatever. This is in C. In C++, well, actually, you could overload the operators to compare structures and whatnot in C or C++. The idea behind it is to create sub-arrays and then swap the sub-arrays if one's smaller, otherwise continue moving forward. So I'll show you what that means in just a second. I just want to compile this really quick. And let's see, that looks right. Okay. And let's see. Good. 09571320. That looks right. So I just wanted to make sure that the array prints out as it should. Array 9571320, 9571320. That looks right. And then we print insertion sort. So this will do the sorting, which I haven't put anything up in here yet. And then print again, and then it should be sorted. So let me put this up here really quick so I can show you what's going on. We're basically going to start at the first index, and since this is in C, I need to put my variables up here, and then we'll create subarrays. But first I just want to get this set up. Length plus j. Okay, so we'll start here at 1 with I equals 1, and then we'll have j. Is I less than j? Well, yes, then we swap. And then it would look something like that. That would be the second iteration, and then I would move up to here. Now, this part's interesting, and I want to show you why we're not really comparing I and j. We're comparing j and j plus 1. So let's look at this. This is now the second iteration. I is equal to 2, and then j would be equal to I plus 1. So I'm going to put that down here. J equals I minus 1. Did I say plus 1? I meant to say j equals minus 1. So I equals 2, which in this case would equal 7. J equals I minus 1, which equals 9. So we compare I and j in this instance, and I'll show you why we're not really comparing I and j, but we compare them. As 7 less than 9? Yes. So we swap them. Now here's the reason why we're not comparing I and j. We decrement j, and now j is equal to 0, but I is equal to, it's equal to 2. Well, if we compare I and j, 9 is greater than 5, that's right, but we still have this here. 7 is greater than 5, which is also correct. If it wasn't correct, for example, if this was like 3, we would have to swap them again. That was probably a bad example because this is already sorted. So let me do another example. Let's say I is equal to 4 up here. This is a better example. So in this case, j equals I minus 1. We compare, yes. 2 is obviously less than 13, so we swap. Alright, so this is a much better example because now j gets decremented. And now if we compare I and j, well, we still have this 2 here. And the 2 needs to get brought down because I is eventually going to get incremented until it equals the length. That's what's going on in this outer loop here. So really what we're comparing is j plus 1. That's what I've been trying to say, and I kind of maybe talked a little bit too much, or it was a little bit too long-winded, but we're comparing j and j plus 1, and is 2 less than 9? Yes, and then we swap, and that's the game here. Then we decrement j, and then this would be j plus 1 and j, and we basically carry it all the way down as long as j is greater than or equal to 0. So I'm going to put this loop here, j is greater than or equal to 0, and array j is, let's see, jj is greater than array j plus 1. And now we swap. And if it's not, like for example here, well, I screwed up the array, but let's say for example here, let's say I equals 2 or 7. Well, is 5 less than 7? Yes, it is. Then we don't do anything, and that's what you see here. So this is the comparison that happens. And if it's already sorted, then we don't have to shuffle the subarrays downward. So let me put this up really quick. array j. So this is the swapping code. If we were using C++, you could just use the STL and swap, but we gotta do this with our bare hands. Array j. Actually, this should be j. This will be j plus 1. And put a semicolon. Array j equals temp. And now we move the subarray downwards. Let's see. Here's where the j equals I minus 1. Here's where the I moves forward. And here's where we create the subarrays. So create and swap subarrays. That's basically it. Let me run this. Let me get rid of this stuff up here because that's not going to compile. And let me see. Uh-oh. What did I do? What did I do? Did I break it? 9.5. So print array. It hung. Why did the code hang? Int j I equal. Oh. I plus I. Sorry about that mistake. So this should only be I. This is where the I moves forward, and here's where we create the subarrays j. That looks good. I didn't realize that. Great. And there it is.